Hey space enthusiasts, welcome back to our channel. Today, we're diving into one of NASA's most astonishing revelations about the smallest planet in our solar system, Mercury. What did the James Webb Space Telescope, JWST, uncover that NASA has been keeping under wraps? Stick around to find out how these findings could reshape our understanding of the entire solar system. You won't want to miss this. The James Webb Space Telescope, launched to succeed Hubble, was built to explore the farthest reaches of the universe. But one of its lesser-known missions was to take a closer look at planets in our own solar system, especially Mercury. Known for its ultra-sensitive infrared imaging, JWST is able to peer through the thick atmosphere and scorching heat of Mercury like no telescope before. Why is this significant? Because Mercury's proximity to the Sun makes it one of the least explored planets in the solar system. Webb's unique capabilities give scientists an unprecedented look into Mercury's surface and atmosphere. Mercury is not just the smallest planet, it's also one of the most extreme. Its surface temperature can swing from a blistering 800 F, 427 C, during the day to a bone-chilling 330 F, 201 C, at night. The planet's lack of a substantial atmosphere contributes to these wild temperature variations. The planet also has the longest day-night cycle of any planet, meaning that one Mercury day lasts nearly 59 Earth days. The unforgiving environment has always made Mercury a tough planet to study, but with the James Webb Telescope's superior technology, NASA scientists are finally able to see what's happening beneath Mercury's surface, and it's mind-blowing. So, what's the big reveal? JWST detected signs of water ice in Mercury's shadowed craters, a shocking find considering the planet's close proximity to the Sun. Previous missions, like MESSE-NGER, hinted at this, but Webb's powerful sensors have confirmed it. These permanently shadowed regions in Mercury's craters never see sunlight, and their cold temperatures allow water ice to persist. But that's not all. The telescope also picked up mysterious signals indicating complex chemical reactions occurring in Mercury's thin exosphere, potentially leading to the discovery of new elements or compounds previously undetected on the planet. The discovery of water ice on Mercury raises important questions. If water can exist on Mercury, what does this mean for our understanding of where water, or even life, can be found in the solar system? Scientists now have to reconsider long-held beliefs about planet formation and habitability. Mercury's extreme conditions have always made it seem like an unlikely candidate for hosting anything related to water. But if ice can exist here, it opens the door to new theories about water reservoirs in even more hostile environments across the universe. Could this be a clue to finding life in places we never thought possible? So what comes next? NASA is planning follow-up missions to study these incredible findings in more detail. The European Space Agency's Bepi Colombo mission, currently en route to Mercury, is expected to provide more detailed information about these water ice deposits and the planet's geology. With JWST continuing to monitor Mercury, NASA is hoping to uncover more secrets about this mysterious planet. The discoveries here could not only alter how we see Mercury, but may also offer new clues about the evolution of our entire solar system. One of the most surprising things about Mercury is its magnetic field. While it's weaker than Earth's, it exists despite the planet's small size and slow rotation. Typically, a planet needs to have a fast spin and a molten core to generate a magnetic field, but Mercury doesn't fit these criteria. So why does it still have one? Scientists believe Mercury's core might be partially liquid, and JWST's data could help clarify this mystery. If confirmed, it could change our understanding of planetary magnetic fields and how they evolve over time. Mercury's surface is home to strange, shallow, bright depressions called hollows. These features were discovered by NASA's MESSE-NGER mission, but remain a puzzle. What causes them? One theory is that volatile materials inside Mercury's crust vaporize due to solar radiation, leaving behind these odd formations. The James Webb Space Telescope is now able to take more detailed images of these hollows, providing new clues. Could these features hint at geological processes never seen on any other planet? Though Mercury seems like a dead, lifeless rock, it may still be geologically active. Recent data from Webb suggests that the planet's surface may have experienced volcanic activity more recently than scientists thought, perhaps only a few million years ago. This is stunning, as Mercury was assumed to have cooled off long ago. Could there still be tectonic or volcanic processes at work today? NASA is hoping further observations will unlock this enigma. Mercury has a very thin atmosphere, known as an exosphere, made up of atoms blasted off its surface by solar winds and micrometeoroid impacts. James Webb's advanced sensors have been able to detect new details about this fragile exosphere, including the discovery of sodium and oxygen traces. Understanding the composition and behavior of Mercury's exosphere could help scientists understand the atmospheres of other small, rocky planets, and perhaps even exoplanets in distant star systems. One of the most striking features of Mercury is its disproportionately large core, which makes up about 85% of the planet's radius. This is much larger than Earth's, and scientists are still trying to understand why. The James Webb Telescope is providing new insights into the structure of Mercury's interior, using infrared readings to probe the planet's density and composition. Could Mercury's oversized core be the key to understanding the planet's unique magnetic field? The data is still coming in, but it's already leading to some fascinating new theories. Mercury's elliptical orbit brings it closer to the Sun than any other planet, leading to significant gravitational effects on its surface. The planet's proximity to the Sun and its unique 2-spin orbit resonance means that Mercury completes 3 rotations for every 2 orbits around the Sun. This creates extreme conditions that James Webb's data is helping us understand better. Scientists are finding that these orbital dynamics cause significant surface deformation, which could offer clues about Mercury's early history and formation. Mercury's proximity to the Sun means it's constantly bombarded with solar radiation. This radiation strips atoms from Mercury's surface, contributing to its thin exosphere. The James Webb Telescope has been able to observe the effects of this radiation more clearly than ever before, revealing how it interacts with Mercury's surface and atmosphere. Understanding how solar radiation impacts Mercury could help us predict how similar processes might affect other planets close to their stars, including exoplanets. Mercury is covered in impact craters, some of which date back billions of years. These craters serve as time capsules, preserving information about the early solar system. The James Webb Space Telescope is providing high-resolution images of these craters, allowing scientists to study their composition in greater detail. By examining the materials inside these ancient craters, we can learn more about the early conditions of our solar system and how planets like Earth formed. The Calariz Basin is one of the largest impact craters in the solar system, stretching over 950 miles in diameter. It's a geological wonder that has fascinated scientists for decades. With the help of James Webb's advanced imaging, NASA is now able to study this enormous feature in more detail than ever before. What caused such a massive impact, and how did it shape Mercury's surface and interior? Webb's observations may provide new answers to these long-standing questions. Mercury's poles are another area of intense interest for scientists. Despite the planet's searing temperatures, its polar regions contain permanently shadowed craters that are some of the coldest places in the solar system. The James Webb Telescope has confirmed the presence of water ice in these craters, but scientists are still trying to figure out how it got there and how it has survived. Could these frozen deposits offer clues about the early solar system? Mercury's surface is scarred by ancient volcanic plains, evidence of massive lava flows that occurred billions of years ago. The James Webb Space Telescope is offering new insights into the composition of these volcanic regions, helping scientists understand what kind of materials make up Mercury's crust. By studying these ancient lava flows, researchers hope to piece together the history of Mercury's volcanic activity and how it compares to other rocky planets like Earth and Venus. One of the key objectives of the James Webb Space Telescope study of Mercury is to determine the exact composition of its surface. Early observations suggest that Mercury's surface is rich in metals like iron and magnesium, which makes sense given its proximity to the Sun. However, Webb's infrared imaging is revealing new details about the distribution of these elements and how they vary across the planet. This could provide crucial information about how Mercury formed and how it has evolved over time. Because Mercury has almost no atmosphere to protect it from space, its surface is constantly bombarded by solar radiation and micrometeoroids. This process, known as space weathering, alters the planet's surface over time. The James Webb Telescope is helping scientists study the effects of space weathering on Mercury, revealing how the planet's surface has changed over billions of years. This could also help us understand how space weathering might affect other rocky planets and moons. Mercury has a very unusual rotational pattern. As mentioned earlier, it has a 3-2-spin orbit resonance, meaning it rotates 3 times for every 2 orbits around the Sun. This unique spin leads to strange day-night cycles and affects the planet's surface temperatures in dramatic ways. The James Webb Space Telescope is allowing scientists to better understand how this rotational pattern impacts Mercury's surface and atmosphere, shedding light on one of the most peculiar aspects of the planet. While Mercury's current atmosphere is almost non-existent, some scientists believe it may have had a thicker atmosphere in the distant past. If this is true, what happened to it? The James Webb Telescope is helping researchers search for clues, studying the planet's surface and exosphere for signs of past atmospheric activity. If Mercury did once have an atmosphere, this discovery could completely change our understanding of the planet's history. Although Mercury doesn't have the plate tectonics we see on Earth, there is evidence of tectonic activity in the form of large cliffs or scarps that stretch across its surface. These cliffs are thought to have formed as Mercury's interior cooled and contracted over time. The James Webb Telescope is giving scientists a clearer view of these scarps, helping them determine when and how this tectonic activity occurred. Could Mercury's interior still be shrinking today? The idea of life on Mercury might sound far-fetched, but some scientists are exploring the possibility of microbial life in the planet's permanently shadowed craters. These regions, which contain water ice, could potentially harbor life forms adapted to extreme environments. The James Webb Space Telescope is playing a key role in this search, analyzing Mercury's surface and exosphere for signs of organic molecules or other indicators of life. Could Mercury surprise us yet again? The harsh conditions on Mercury mean that its surface is constantly subjected to weathering processes, primarily due to solar radiation and micrometeorite impacts. This weathering causes the surface materials to break down and change color over time. The James Webb Space Telescope is analyzing the mineral composition of the surface to better understand how these weathering processes work. By examining the spectral signatures of different materials, scientists hope to reveal the history of Mercury's surface changes and how they compare to other rocky planets. Mercury's exosphere is incredibly thin, composed mainly of oxygen, sodium, hydrogen, helium, and potassium. This fragile atmosphere is constantly being replenished by solar wind and impacts from comets and meteoroids. The James Webb Telescope is uniquely positioned to study this dynamic environment in unprecedented detail. By tracking the variations in Mercury's exosphere, scientists can gain insights into how solar activity influences atmospheric conditions on the planet, as well as the implications for other planetary bodies with thin atmospheres. The solar wind plays a critical role in shaping Mercury's surface and atmosphere. As particles from the Sun bombard the planet, they strip away surface materials, altering its landscape. The James Webb Space Telescope is providing new data on how solar wind interacts with Mercury's surface, revealing the processes that contribute to the planet's geological features. Understanding these interactions is crucial for comprehending how solar winds affect not only Mercury, but also other terrestrial bodies in our solar system. Many discoveries made by previous missions, such as MESSS, NGER, and Mariner 10, can now be revisited with the advanced capabilities of the James Webb Space Telescope. For instance, the findings about the chemical composition of Mercury's surface can now be confirmed or revised using Webb's infrared technology. This ability to reassess past discoveries opens new avenues for scientific inquiry, allowing researchers to build a more comprehensive picture of Mercury's geological and atmospheric evolution. One of the most significant mysteries surrounding Mercury is its internal structure. Scientists believe that it has a large metallic core, but the exact details remain unclear. The James Webb Telescope's observations are helping to refine our understanding of the planet's density and composition. By studying gravitational interactions and thermal emissions, researchers aim to map out Mercury's internal structure in greater detail, leading to insights about its formation and geological history. Interestingly, studying Mercury can also provide valuable insights into planets that orbit other stars. The conditions on Mercury may resemble those of some exoplanets located near their stars, particularly in terms of surface temperatures and atmospheres. The data collected by the James Webb Space Telescope will not only deepen our understanding of Mercury, but could also serve as a comparative framework for studying potentially habitable exoplanets in the future. Mercury's surface is a complex mix of geological features, including smooth plains, rugged highlands, and massive impact craters. The James Webb Space Telescope is able to provide detailed images of these terrains, allowing scientists to categorize and analyze them more effectively. By understanding the history and formation of these unique terrains, researchers can gain insights into the processes that shaped not only Mercury, but also other terrestrial planets in the solar system. While Mercury and Earth are vastly different in many ways, studying Mercury can help scientists understand more about Earth's history and evolution. For example, both planets experienced similar processes of formation and cooling, but Earth developed a much thicker atmosphere. By studying Mercury's geological history, we can draw parallels to Earth's early days and gain insights into how our planet developed its protective atmosphere, which has allowed life to thrive. The success of the James Webb Space Telescope can be attributed to its advanced technology, including its NASA and various educational organizations are using these findings to inspire interest in space science and exploration. Interactive educational materials, online resources, and public outreach programs are making it easier for everyone to learn about Mercury and the work of the James Webb Space Telescope. Engaging the next generation of scientists and explorers will be vital for the future of space exploration. The findings from the James Webb Space Telescope represent a significant achievement in international collaboration. Various space agencies and institutions worldwide have contributed to the telescope's design, launch, and data analysis. This collaborative spirit fosters a sense of unity among scientists and researchers, allowing them to work together toward common goals in understanding our universe. Mercury's position as the closest planet to the Sun makes it a unique laboratory for studying solar phenomena. By observing how solar radiation affects Mercury, researchers can gather insights into solar activity that can inform our understanding of the Sun's influence on the entire solar system. The data from the James Webb Telescope will enhance our knowledge of solar terrestrial interactions, with implications for understanding space weather and its effects on Earth. The James Webb Space Telescope is just the beginning. As scientists continue to analyze the data being collected, new questions and avenues of research will emerge. Future missions to Mercury, such as BP Colombo, are set to launch and will further explore the planet's mysteries. The combination of JWST's observations and new missions will undoubtedly advance our understanding of Mercury in exciting ways. Understanding Mercury is not just about studying one planet. It has broader implications for planetary science and our understanding of planetary systems. By piecing together the complex history of Mercury, researchers can apply their findings to other rocky planets in our solar system and beyond. This can help refine theories about planet formation, atmosphere development, and the potential for life on other worlds. Throughout history, Mercury has held a significant place in various cultures, often associated with speed and communication due to its swift orbit around the Sun. By highlighting Mercury's cultural significance, in addition to its scientific importance, we can foster a deeper appreciation for this fascinating planet. Engaging with its historical context allows us to connect modern scientific discoveries with humanity's long-standing fascination with the cosmos. Citizen science initiatives are becoming increasingly important in space exploration. As the public engages with data from missions like the James Webb Space Telescope, they contribute to the scientific community. Citizen scientists can help identify patterns in data or even assist in analyzing images. This collaboration between professionals and amateurs enriches our understanding of Mercury and enhances public interest in science. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.